Hey, welcome to a series of presentations on measurement, and this is part one, looking at measuring length. Have a look at this question I've got for you here. Could you build this? What? Any of this or this? Oh, how intricate is that? Pretty hard to do, I would imagine, and maybe, just maybe, you might need to be able to measure stuff. You have to have exact lengths for all this to fit together. So the beginning of all this sort of construction and architecture might be the ability to measure. So let's do it. Let's have a look at measuring stuff. And how do you do it? How do you do it? Well, we're going to use a metric system which is based on meters and kilograms, and it's a decimal system in bundles of hundreds and tens, based on tens, and then hundreds and thousands. And we use Greek prefixes. Prefixes means words coming before others, so little words like kilo, kilometre or kilometre means 1,000 of the base unit. So if we make the base units larger, bigger bundles of them, like 1,000 of them, are called kilometres or kilometres, and mega bundles of them, megametres, are 1,000,000 metres. Okay, so we use the Greek letters to make up bigger bundles, larger numbers, and we use the Latin letters in front, or prefixes, pre coming before. Centi means 1/100th of a metre, so it's a smaller unit. So we use these prefixes before for smaller portions. A millimetre is 1,000th of a metre. So do you get the idea? This is a common way of using or describing the base units, or the units we're using for larger and smaller quantities, away from the base unit. And of course the base unit in this system, as I've already mentioned, is the metre. The metre is the base unit of length in the metric system. And the kilogram is the gram, is the base unit of weight in the metric system. But here's the question: how do you make sure everybody's metre on every tape measure around the world is always the same? How do you make it consistent? Well, there's a bit of history here, so you might be interested in that. So come down, and here's the history. These screen clippings are from Hayes and Harris Publications, so you should go and get their book. So originally the metre was to be 1/10,000,000th of the distance from the North Pole to the equator, along the line of longitude through Paris. They did a lot of surveys and got exhausted by the looks of things. They worked out that there was a piece of platinum alloy, because that's a metal that's hard to destroy, would be kept as the standard metre, which was 1/10,000,000th of their estimated distance from the North Pole, to the equator. Okay, and this was kept near Paris. Serves near Paris. So it wasn't easily accessible to people around the world, and also it could get damaged, even though it was platinum alloy, which is pretty resistant to damage. They didn't want it damaged. That was our only standard. So then in 1960 they tried to, in between those years, 1960, 1983, they tried to define it in terms of something that couldn't be damaged. That was the wavelength of orange-red light from the isotope Krypton-86, and it was defined as many, many wavelengths of that. The idea being that no one could destroy that, and it would be lost to everybody if they did. And it was to be measured in a vacuum, so there was some consistency there, and anyone around the world could set up the scientific experiment to make sure they had the right wavelength. But then again, one could say, well, Krypton, what if that disappeared from the face of the Earth? Would that be any longer consistent? So in 1983, they redefined it as the distance light travels in a vacuum. So all you need is light. And of course, light travels very quickly. So it's only 1/299 billionth or something of a second. So it's in a very small part of a second that light will go a metre. But we're looking for consistency that can't be destroyed over time, so that the metre always remains exactly the same. There'll be errors in making up tape measures and stuff, but we can refer back to something that will be constant and consistent. So get the idea, a fair bit behind just picking up a tape measure and measuring, isn't there? Let's have a look now and see about our units. So 1 kilometre, means it's a big unit. There's 1,000 of our base units in it. 1 centimetre, centi is 1/100th of a metre. Centi, 1/100th of our base unit. And 1 milli is the Latin again, is 1,000th of our base metre. Or looking at going from there to there, if you find 1/10th of 100th, you've got 1,000. So it's 1/10th of a centimetre. And here they are, a kilometre, about 2.5 laps around the oval. Ovals vary a lot though, so there's not much constancy there. That's allowing for an oval to be about 400 metres around. The width of a fingernail, but that will vary too, or about the width of a coin, but coins vary. So, hard to say here, isn't it? But about the width of a coin means the depth of a coin. All right, so I'll give you some idea of our units. So they're bigs and they're smalls, depending upon what you want to measure. Let's come down and look at how we would change from one to another. So if we had a big unit, like a kilometre, and we want to change it to a smaller unit, like a metre, there'll be many more of the smalls, won't there? Because one large contains many smalls. So we want to get a bigger answer, we'll multiply. So 2 metre is going to, that's a big measure compared to the centimetre. There's 100 of the little dudes in each metre, so we will multiply. We know that we're going to have many more smalls than larges. We've only got 2 large ones, but we're going to have 200 smalls contained within them. If we're going from a smaller unit to a larger unit, we've got to bundle our smalls up to make our larges. And so we're going to divide. We're going to ask, how many thousands have we got in 2,000 metres? And we've got 2 lots of them, so we've got 2 large. We're going to have 2 kilometres. So let's have a look at the little rule here. Larger to smaller, you're going to have more of them. You will times by whatever number goes with that prefix, the number in front. And here we're going to go from smaller to larger. We actually have to divide. Okay, well, have you got the idea? Hopefully you've seen a bit of this before, but not to worry if you haven't. Let's go down and try and summarise that a little here. Do you get it? What we're doing is going from a large to a small, we're going to multiply. And to smaller, we'll multiply again. And to smaller, we'll multiply again. Coming back, millimetres into the larger unit of centimetres, we'll divide. We have to find how many bundles of smalls there are to make up a large. And bundles in a total is division. So how many centimetres make up a metre? We will have to bundle them all up into hundreds. So we will divide. There'll be a smaller number of those larger units. We're bundling them up and finding how many metres there are in the kilometre. We want bundles of 1,000. We'll divide up our metres into bundles of 1,000 to find how many kilometres or kilometres there are. Kilometres, we say. All right, do you get it? Let's go down and practice some stuff. So here's some examples from Hayes and Harris. So we've got 3.2 metres and we want to change it to centimetres. Metres is larger than centimetres. We're going to have more centimetres. We will multiply by 100 because the prefix coming before the main unit, centi, the prefix in that word, the first part of the word, means 100th. So go times by 100, which is 320. 423 millimetres into centimetres. These are smaller than centimetres. So therefore we've got to bundle them up into groups of 10 to make centimetres. We'll have less, so we will divide. 6 kilometres into centimetres. Change it first by timesing to the smaller unit of metres. And then we'll do it again. because metres have other smalls within them. 100 centimetres in a metre. So we've got 600,000 centimetres. Do you get the idea? If you're making smaller units, going to have more, you'll times by the factor. And if you're making larger units, you'll have less of the bigs. You've got to find how many of the smalls divide into it. So you'll be dividing. Your turn. Let's have a go now at some questions. So here's question 1 to 4, or 1 to 5. So I want you to pause the presentation and have a go. And I'm going to show you the answers afterwards. But I think as you do a question, you should actually toggle forward and make sure you're in the ballpark there. Make sure you don't do them all and find they're all wrong. So go forward or look in the back of the book for the correct answer. All right, I'll go on now to the others there. 5 we did, and there's down to 8. I don't think we can get it all on, no. Okay, so pause that. And I'll show you 8. The rest there of 8. Okay, conversion of units. All right, let's have a look at the answers now. Question 1 to 8. And there they are. That looks good. Okay, let's move on. A little bit more measurement coming up. And another example. Adding up things. Hey, how would you work out the total length of the cement to go across the top of those pillars on that opening screen? Well, you'd have to add up distances. I don't think they were kilometres though. Might have kilometres, metres and centimetres. And we'd probably change it to the middle unit, our base unit, which is metres. So 3 kilometres, making smaller units, you'll times by 1,000. 350 metres is already in metres, so leave it. 220 centimetres are smaller units, smaller than metres, so we're going to have to divide by 100 to see how many metres we've got in 220 centimetres. So if you put it all in our base unit and add them up, we've got 3,352.2 metres in total. All right, so we need to be able to change back and forward to accommodate different size objects that we might be dealing with. So do you want to have a go? Let's have a look now at these. So for question 9, changing in to the unit that they've suggested here. So a common unit in the middle. Okay, remember, if you've got bigs and going to smalls, you'll have more smalls. And if you've got smalls going to bigs, you have to find how many bundles there are in the total. You will divide. Okay, pause the presentation, have a go. I'll show you the answers now. All right, I hope you're getting some right there. Okay, let's go on to the last little bit and see what you think. Here's another example to show you the way. And this is getting into the practical area now. Calculate the number of 50-metre laps Ian swims in his 4.2 kilometre pool session. Number of 50-metre laps if he's going to make 4.2 kilometres. So you want to know how many of these there are in this. That's going to be division, but hang on, we've got to get the units right. They are metres, they are kilometres. So we better first change our kilometres to metres. Now kilometres is big unit, bigger than metres, so you're going to have more metres than 4.2. Therefore you'll times by 1,000 to get how many metres there are in 4.2 kilometres. Got to keep common units here. If you're going to try and work out how many you've got, you have to have common units. So dividing by 50 metres to find how many laps there were in 4.2 kilometres, he's got to swim 84 laps. Wow, what a dynamo. Wish I could do that. Okay, let's have a look at some problems along the same lines. Sorry about that. Let's come down here now and have a look at our last little set of problems. Calculate the number of 8-metre pipes. Watch the units, watch the units. They've got to be the same. We've got to work out a common unit there and work with that. So I want you to try those little practical problems. I hope you're getting excited here about how useful this could be in answering some small but practical questions. Okay, pause the presentation and have a go. I'm going to show you the answers now. There we have our answers. So I hope you've enjoyed this first little measurement introduction, and we're going to measure all sorts of stuff, and you'll say, hey, I can see how this is going to be useful. This is a useful area of mathematics. For now, though, it's cheers from me.